Hey guys, today let's discuss this problem. So as always, we are going to start with the example. So in this problem, we are going to have a um, list of spots. So for example, in this example, we are going to have 5 spots, right? So we only consider these 5 spots, and we are going to have 3 colors. And this is a array saying that how long can we color the continuous spots with a color, right? So what does that mean? So we have 3 colors. For the first color, we are going to we have to color 3 continuous spots, right? Like this. And for the second color, we are going to have to color 2 continuous spots. For example, we can color this 2 or this 2, right? So let's say we color the first 2, and in this case, the blue color will be override by the red color. So the blue color doesn't exist at these 2 spots anymore. And for the third color, also we are going to have to color 2 continuous spots. For example, we can color these 2 spots. In this case, we override the third spots with the green color. So in our graph, the blue color doesn't exist anymore. So the goal of this problem is to find a way to color all these spots so that the final results satisfy 2 conditions. The first condition is that all of these spots has at least 1 color. For example, in this case, the 5th spot doesn't have a color, so it is not satisfied the first condition. And the second condition is that all of these colors appears at least 1 spot. So in this case, blue color is overridden by uh, the following colors, so it doesn't exist in the graph anymore. So it is also not satisfy the second condition. So what is the way to color the spots satisfy all of these conditions? So as we can see, for these 5 spots, right? First, for each spot, we are going to, for each colors, we are going to find a starting spot and coloring the starting spot and the following continuous spots, right? So for the first color, we are going to um, start with the second spot. So we color the second spot and the third spot and the fourth spot, 3 continuous spots, right? And for the second color, we're going to start with the fourth spot, right? We're going to start this one and color 2 continuous spots. And for the third color, we're going to start with the first spot, right? In this way, each of the spots has a color, right? And each color appears at least 1 spot, right? So blue appears here, red appears here, and the light blue appears here, right? So in this way, the final spots satisfy the 2 conditions, so we can output the result here. So how do we solve this problem? So as a guideline, we're going to have two intuitions. The first intuition is that to satisfy the first condition, uh, that means we are going to cover all of the spots with at least one color, right? So let's say we have a spot list like this, and we have colors like this. So the most spots we can color with this colors is 7 spots, right? If we because if we sum up them together, we can cover 7 spots, and that means we don't have overlap between two colors, right? So if we have 8 spots, that means at least one spot will not has the color, right? And that's the first intuition. If we have a lot of spots, we need to just lay out the spots, lay out the colors on the spot, and we don't want any overlap between colors, right? And the second intuition is that if we don't have so many spots, that means let's say we only have 3 spots here. And how do we put these 3 colors in those spots? So we are going to make sure every color and only occupies one spot, right? So in this case, we're going to color the um, first spot and the following 2, right? And then we're going to color the second spot with the second color, right? And for the third color, we are going to cover the next spots. But in this case, if we color at spot 3, we're going to have we are going to color 2 spots. But in this case, we don't have spot 4 here, so we need to output -1 because we can never find those colors that satisfy all those conditions, right? So that's 2 intuitions here. So these 2 intuitions deals with 2 is extreme cases, right? The first extreme case is that we have too many spots and we have to overlay the colors on those spots without any overlay between colors. And the second intuition is that for those cases we don't have so many spots, we have to overlay the colors as much as possible so that every color only occupies one spot, right? So with that being said, we are going to just discuss the overall algorithm. So we are going to iterate through all of these colors. And for each color, we are going to find a right start point. So what is the right start spot for that color? That depends on how many what is the most range we can cover with the rest of the colors. In this case, we are going to have 7. We at most have 7 spots covered with the rest of the color, right? And we are going to calculate how many spots left, right? Let's say we have 5 spots left. That means we need to overlay 2 spots so that we don't have we don't have too many colors, right? So for those uh, So for those cases, we have too many spots where let's say we have 9 spots left. That means we can never cover those cases with the rest of the colors. So we return -1 in those cases, right? So let's take a look at the code here. So the code is quite simple. First, we are going to read all of the length of the colors, right? And we are going to save the starting point for each color in this array, right? And for P0 and P1 here is for each color we are going to find a starting point for that color, right? And that start point can be choose from uh, P0 to P1, right? What does that mean? That means our previous color occupies uh, this 5 spots so that the next color we can choose the starting point from here, right? We can left only 1 spot for the previous color, and we can choose here, also here, and also here, right? Um, and also here. In this case, if we choose this spot, that means we don't have any overlay with the previous color, right? So we have 5 options, and P1 is actually here. So the next starting point we can choose from these 5 spots. So this is where we check if the rest of the spots is bigger than the is this is the rest of the spots, right? And this is the biggest area we can cover with the rest of the colors. If this guy is bigger than this guy, then it means we don't have enough colors to cover rest of the spots. We can output -1 here. And here is where we calculate the starting point. So for this guy, that means we need to make sure we choose the starting point from P0 to P1, right? And this guy is ensure that if we have too many spots, then we don't need any overlay between 2 colors. If we don't have too many spots, that means we might need some overlay. And let's say if we have 5 uh, extra spots, we are going to choose the leftmost spot as the starting point. If we only have 1 additional spot, we are going to choose this guy as the starting point. Why? Because that means we have 1 more overlay for our spots, so that we don't have to uh, deal with the additional uh, spots with the color, right? And that's it. So here we calculate the starting point and we push it into the answer, right? And we are going to assign the new values for the for the next coloring range, right? Next coloring will choose from P0 to P1, right? And this is also a uh, extreme case where we have we already exceed the P1 here is the end point of the coloring, right? If the P1 is bigger than n, that means the current coloring exists the range um, of the spots. Let's say this is our list of spots, and our P1 is here. That means the last coloring spot is outside of the range, so we have to output a -1 here. So if we did this for all of those colors, that means we can output the answer, right? So I guess that's it. Hope it helps. See you next time.